So in this segment, I'm going to talk about the benefits and drawbacks of the microservice architecture. So let's first look at the benefits, of which there are quite a few. So one major benefit of the microservice architecture is that you have smaller, simpler applications. That makes them easier to understand and develop. You can think of each microservice as sort of being an amount of code that can fit in a developer's head, right? So we understand completely how it works. Unlike in a monolithic application where you've just got this massive application and it's beyond human comprehension. Another benefit of having smaller, simpler applications is that you're going to have less dependency conflicts on the class path. Right? That's quite common in these very large applications. And if you think about it, OSGI was intended to solve problems like this. But if you've got smaller, simpler applications with a relatively simple class path, then the motivation for using OSGI sort of goes away at that point. Another nice thing about these applications is that they're going to be faster to build. There's simply less code to compile, and also faster to deploy. Smaller jar file, WAR file, or whatever your packaging unit is to copy around and so on. And then they're also likely to be much faster to start up. These are much smaller applications, and so you're not going to see very, very long startup times. Hopefully each service will start up within just a few seconds, which is nice both from a development perspective, but also operationally as well. Another nice feature of microservices is that each microservice can be developed independently of other microservices. It can be deployed independently, and it can also be scaled independently as well. So for instance, if you're working on the user interface, and you want to run A/B testing, you can and iterate rapidly on the design. You can make changes to the UI and redeploy it without having to redeploy the rest of the system. So you don't have to coordinate with anyone else. You can just go ahead and deploy your part of the system. And provided that everyone is honoring the contracts between the various components, you're not going to have problems. Likewise, someone working on a back-end component can develop and deploy and then scale independently of other services within the application. Another nice benefit of microservices is that it improves fault isolation. If, for example, you have a memory leak in a module within a monolithic application, that will actually could potentially take down the entire monolith. Whereas in a microservice, a memory leak will only impact that one particular service instance and generally leave the rest of the application unaffected. Another major benefit of using microservices is that it eliminates any long-term commitment to a single technology stack. Whenever you build a new service, in theory, you are free to adopt whatever technology makes sense for that particular service. Just because you started with one particular technology, it doesn't mean that when it's time to build a new service that you have to keep using that same technology. So, for example, if someone on your team felt that it was a great idea to use Haskell to implement a particular service, and assuming that they can implement the required interface, then there are no technological constraints that would prevent them from doing that. And it turns out Haskell's a fascinating language, and it's worth taking a look at. But of course, in general, you actually need to have some level of sort of governance to constrain the technologies that you're going to use within your system, because if, say, a particular your Haskell developer leaves, then perhaps you're going to have an issue maintaining that piece of code. So you want to put in place sort of mechanisms to or sort of governance mechanisms to constrain the technology choices, but at least there are no technological constraints on the technologies that you adopt. So you end up sort of moving into this world where you've got modular systems which are polyglot in the sense that you're using a variety of languages, and they're also multi-framework. Within a language, some of your system could be written using Spring, other parts could be written using Java EE, and other parts could be written using Play. It's whatever makes sense for a given service. So you can think of your system as really having two different levels of architecture. There's sort of the system level, where you're saying, these are the services we're going to have. Each service is going to have this interface, and they're going to communicate using these mechanisms. REST for synchronous communication, and say RabbitMQ for asynchronous communication. And that's sort of the slow changing, more traditional architecture. And then each service can have its own architecture. And each service could use a different technology stack. You can pick a different tool for the job, and this level can rapidly evolve. So when you're implementing a new service, you can pick a new technology, or say if you're making changes to an existing service, you could actually rewrite it and upgrade the technology stack. You're not constrained, and so you can pick and choose as you go along. And then another really neat aspect of the microservice architecture is that it lets you easily experiment with new technologies. So if, say, one of your developers decides that they're going to spend 2 weeks writing a service using Golang, for example, and they succeed, then that's great. You've introduced a new technology into your organization, and you can consider using it for other services. But if, on the other hand, that whole experiment fails, then you've only wasted 2 weeks. It's not a major disaster. And you've also learned something as well. You've learned, say, that you need to use a higher level language. And so this approach lets you try new technologies as you discover them and sort of fail in a very safe way, which is, I think, awesome, really is good. Okay, so those are the benefits. Let's go look at the drawbacks. So by far the biggest the biggest drawback of microservices is really complexity. It really does introduce a higher level of complexity into your system. But the nice thing is that unlike a monolith, which is complex, and in a way that you can't do anything about, the ways in which a microservice architecture is complex is a little different. There are ways of tackling this complexity. So, for example, one kind of complexity that you're now having to deal with is that you are now building a distributed system. So what that means, for example, is when module A calls module B, in a monolith, that's just a language level method call or a function call. Because this is a distributed system now, you're actually having to do inter-process communication. So you have to pick some kind of IPC mechanism, whether that's REST or messaging, and you have to implement it. Not only that, you have to deal with the issue of partial failure. The remote service that you're trying to access could be very, very slow. It might not respond within an acceptable time period, or it might actually be down. So that's a whole new level of complexity that you did not have to deal with in a monolithic architecture. I'm going to talk more about partial failure, but the good news is that there are actually frameworks that can help you with that. Another problem that you have to deal with as a developer is in a microservice architecture, not only have you broken up the application into services, but you've also broken up the database. So each service has its own database. And on the one hand, that's great because it's promoting loose coupling. On the other hand, it actually introduces a level of complexity. For instance, if you want to implement a business transaction that spans multiple services, you can't use ACID transactions anymore. You can't use distributed transactions because of the CAP theorem and so on. So you end up having to use a different programming model where you actually end up implementing these event-driven, eventually consistent transactions. So that's a different and slightly more complex programming model than what you might be used to. So another way that microservices introduce complexity is when it comes to testing. So let's imagine that I just have a monolithic application and I've implemented it using Spring Boot. I can write a JUnit test case, and with a couple of annotations, I can write a test that will actually spin up my application, and then I can test the user interface using Selenium. Or perhaps I'm going to test the REST API directly. So that's fairly straightforward. Now the trouble is, in a microservice architecture, you want to test service A, but that calls services B and C. So the issue is, well, what does my test do? Does it spin up A and B and C? Maybe that's sort of like, you can do end-to-end testing, but that's another level of complexity that you now have to worry about. Martin Fowler's actually written a really great article about this, which I encourage you to look at, and he actually talks about different testing strategies that you can use in your microservice application. And the short answer is you end up with this like testing pyramid where you try and do most of your testing near the bottom of the pyramid, where you're writing fast running, reliable, easy to develop sort of unit and integration tests, and do very little testing at the top of the pyramid because that's brittle, slow, and costly. But there's added complexity here. So another way in which microservices add complexity is operationally. So whereas before you had a monolith that was one thing, and you just had to run multiple copies of it in production, but they were the same thing, and you just sort of had to do the same thing on multiple servers. In a microservice architecture, you could actually have tens or hundreds of these individual services that are potentially all slightly different. They might use different languages, different technologies, and so on. And so you've got many more moving parts to orchestrate in your production system. The good news is that there are solutions available for automating a lot of this, which ends up reducing the pain, right? So for example, you could use a PaaS like Cloud Foundry. Or perhaps you could use some Docker clustering solution like Kubernetes or Mesos Marathon to sort of automate the deployment and management of your infrastructure. So even though there is complexity, solutions do exist to that problem. And then another issue that you have to deal with is that developing and deploying features that span multiple services can require a lot of careful coordination and communication between teams. So imagine that you're implementing a new feature and it impacts service A and service B and C. And A depends upon B, which depends upon C. So one of the challenges you face is that you have to make changes to all three of those services, which in itself is not a problem as such. But then when it's time to roll out that new feature, deploy it, you have to have a deployment plan that involves deploying service C first, and then deploying B, because B depends upon C, and then finally deploying A. So there's a lot of planning. Whereas, ironically, in a monolithic application, you just make a bunch of changes to various modules, commit the code, and then deploy this monolith, and it's one simple a one-step deployment. So it's sort of, they end up being mirrors of one another. And then finally, the issue that you have to deal with microservices is deciding when to use them. So, and that this is a question that is very context dependent. So, for instance, if you're a startup, you're just getting going, you actually haven't really figured out what your business model is, and you don't actually have any customers. And so you actually don't have any, and you don't have much code either. So in other words, you don't have the problems that the microservice architecture solves. If you were to actually use the microservice architecture, it would potentially slow you down. You might actually be able to iterate faster with a monolithic architecture. The trouble is, later on, let's say you've actually figured out your business model, you might actually be profitable, and you have a lot of customers, and you've got a big code base. And this is the point where you might actually need to use the microservice architecture. The challenge that you have is that your code base is sort of tangled, and perhaps it's even a big ball of mud. And then the challenge is sort of modularizing your application and migrating it to a set of microservices. And so it's kind of problematic. You don't need it in the beginning, and migrating to it later on can be a challenge. So that's an issue, deciding when to use it. If, on the other hand, you know that you're building something big from the get-go and you have a big team, then that makes the selecting a microservices architecture a much easier decision. It's also worth noting that while microservices are in themselves quite necessary for a lot of applications, they're also somewhat insufficient as well. Because not only do you need the right architecture, one that's based on microservices, but there's all these other things that you need to have in place. So from a deployment perspective, you need to have continuous deployment. You need to have a virtualized or containerized infrastructure. And you just generally need to have a high level of automation. So you need to have those things in place before that you can fully take advantage of the microservice architecture. Likewise, on the people side, you need to have an organizational structure that mirrors the microservice architecture that you're trying to build. So it's kind of an application of Conway's law. You also need to have agile processes in place as well, right? If you actually still have sort of a waterfall model for developing software, then you can't really take advantage of kind of the benefits of microservices. And then also you need to have DevOps as well, and so on and so forth. So there's a whole bunch of other things that you need to have in place for deployment, and sort of people related and process related things that you need to have in place in order to fully take advantage of the microservice architecture. So sort of in summary, right? So microservices have some tremendous benefits, but they also have a lot of complexity as well. But if you're building a large, complex system, usually the benefits of a microservice architecture will actually outweigh the drawbacks. And also, there are solutions to various different aspects of the complexity of a microservice architecture. But if you do go down the route of microservices, there's a whole bunch more issues that you have to address. How do you deploy the services? How do the services communicate? How do clients of the application communicate with the application, which now consists of a whole set of services? And then how do you partition the system into a set of services? And I'm going to cover these topics in the following segments.